Hi everyone, my name is Olga Gali and I'm a PhD candidate at Pompeu Fabra University in Barcelona. Before going into the details of the study presented in the paper, I would like to start with a question. How do you think we can encourage children to adopt a more positive attitude to interact with their peers? To address this question, I would like to introduce the concept of interpersonal synchrony. This mechanism, while studied in psychology, involves the conscious synchronization between two or more individuals to a common rhythm. Various studies have shown that interpersonal synchrony among children can enhance social bonding and promote prosocial behaviors. Therefore, these strategies are particularly valuable for fostering more positive social interaction contexts, especially beneficial for children with social communication difficulties, such as those on the autism spectrum. However, there are some limitations in current studies evaluating prosociality. The activities conducted are difficult to adapt to settings involving more than two individuals. In cooperative tasks, such as the one presented in that image in Kirchner and Tomasello cooperation, is constrained by the physical apparatus used, limiting the child's freedom of movement. To address these limitations, our study presents the design of a full-body experience within a mixed reality system, leveraging its potential to create environments where users interact with the whole body in a collocated and non-invasive manner. This study is part of a broader project, where through the design of an interactive experience called Dragonize, we aim to first mediate interpersonal synchrony among 4 children, and second, evaluate how this synchronized activity promotes increased prosocial behaviors. In this presentation, I will focus on the second part of the experience, where we design a full-body mixed reality environment that promotes a neutral and adaptable play setting, ideal for exploring and assessing the natural dynamics of children's play preferences. The experience design was carried out through a participatory design process with 50 children aged 8 to 10 in their school classrooms, in 2 sessions of 90 minutes each. During the first session, the children created the game's narrative and objective. Divided into pairs, each subgroup contributed to a cumulative story, co-created by all the children. During the second session, the children created mid-fidelity paper prototypes of the embodied experience, applying the well-established small-scale prototyping technique. Due to time constraints, more details about the activities, the analysis, and the results can be found in the article. Then, the initial design, based on these sessions, was developed in Unity, generating a 6x6 meter flow projection. As we can see from the video, at the beginning, the environment is presented from a bird's eye view, allowing children to see the entire game setting. The design tells the story of a dragon who, after being trapped under an ice surface by two characters in the first part of the experience, is now free but struggling to find its cave because the environment is covered with snow. As the dragon searches for the cave, a volcano suddenly erupts, melting the snow, but also causing the destruction in the environment. At this moment, the 2 characters who had previously trapped the dragon realize their mistake and decide to guide the dragon back to its cave. However, due to the destruction, they require the players' help to repair the road and advance with their vehicle. The experience is structured in 2 phases. The first phase, the children have to rebuild a road of stone slabs, grabbing, carrying, and placing them in their corresponding places, marked by footprints. In total, there are 24 stones of 4 different types. In the second phase, the children rebuild a log bridge. In total, there are 24 logs of 4 different types, as you can see now in the video. This type of experience that provides a free play environment without promoting either individual or collaborative play, we identified the following key design elements as especially effective. Player actions. In this case, we found that children prefer actions similar to those in real life, such grab, move, and place. These actions must be carried out both individually and collaboratively, without reinforcing either modality. Object types. We found that children prefer objects similar to those in real world as well. This can be done by using different textures and shapes. Object allocation in the environment. We found that children had a preference for placing main elements centrally, with secondary elements distributed homogeneously around this central element. Instructions. The gameplay options should be presented without mentioning whether the action is individual or collaborative. Constructs. A clear distinction between individual and collaborative play modes should be predefined to facilitate later analysis. More details on the design elements can be found in the article. As a final step, the resulting design was evaluated in a usability study with the 44 children who participated in the participatory design. In some groups of 4, the children performed the experience on the full body mixed reality system, completed a demographic and user experience questionnaire, performed an activity which they provided feedback of their experience, and did a reflective activity. The key findings from this study include user-system interaction. The children found that the activity easy to engage with, although they encountered some challenges such as positioning and rotating the stones in the road reconstruction task. For the play modes, the children perceived both individual and collaborative play options equally in the questionnaire responses. And for the children's satisfaction and design outcomes, we found that children express high satisfaction with the game, enjoying the experience and appreciating how their ideas were incorporated into the design. The type of data collected, the analysis methods used, and all the results are detailed in the article. Despite the positive results, we recognize the need for ongoing iterations in the design to incorporate the children's feedback to further improve the experience in the future. As a conclusion, with the present study, we present a detailed embodied participatory design process involving 50 children aged 8 to 10 years to design full-body mixed reality experiences. The article includes details about the activities and evaluations to assist other researchers in future adaptations. And secondly, by overcoming the traditional limitations of dyadic and apparatus-based activities, we created a mixed reality environment that enables face-to-face collocated interactions in a free environment game suitable for multiple players. Our results confirm that the resulting design allows children to freely choose to engage in individual or collaborative play without encouraging either modality. Thank you very much for your attention.